Okay, so we'll continue. Welcome back. So now I know the formula for my straight line, but I like to plot that on a scatter plot. Now, of course, if you have graph paper and you have plotted out by hand all the points on the graph paper, you could take that equation and just by solving for if you choose two x's, like say you chose an age of 30 and an age of 60, plugging them into the formula and solving for y, and you'll have two predicted values, and connect those 2 points with a straight line, you'll have drawn in your regression equation. But how do you do this with stata? So with stata, what you do is the following. I'm going to give the command scatter y hat. Now, this expression takes a little bit of explaining, because what's happening in this expression is that stata is going to plot on the same set of axes. It's going to plot the data points, the original data points, and it's also going to plot the regression line. Okay, in fact, I did this an additional time where I drew the regression line initially with the outlier in it. That's this top one. And then I threw the outlier out and I have the bottom one. So I actually have two graphs drawn on this one. But the basic command is this. This says scatter, and there are going to be two plots that are going to be drawn. One is going to be plotting y hat versus age. Okay, now the way you do this is when you have when you're in stata, and perhaps I'll just divert for a second here. Let's go back to stata, and I'm going to call up the data file that I have. Okay, so here we're back to this data file, and let's say I want to do a regression analysis where my dependent variable is blood pressure, my independent variable is age. So I would give the command regress that says do a regression analysis. Systolic blood pressure is the dependent variable, and the independent variable is age. Okay? And I do that, and I get stuff that we don't know how to look at yet. That's going to be what we're going to be doing in this course. But we get the regression analysis. But we do know, look here, here's the slope is 0.97, and the intercept is 98.7. So I have the regression model that is produced by this command. And then if I give the command predict y hat, now this is simply a command that says to stata, compute the predicted value of y given x for each person. And if I say that, then basically what it did is that in the data file, you can see that it now has y hat. It has the predicted value of y for each and every person in the sample. Okay, so if you tell me that the person's age is 39, I plug 39 into the regression equation, and I get the predicted value of 136. So I would have predicted that this person's blood pressure would be 136, 136.5787. In fact, it was 144. So the person's blood pressure is a little bit higher than expected based on the model. But the point being that this command that I said, predict y hat, simple command, estimates the value of y for each and every person in the data file. Okay, so we can go back. And what I'm doing here is, again, I'm asking it to do two scatter plots. One is to take that variable we created, y hat, and to plot it versus age. And the second graph is to plot the original blood pressures versus age. So the original blood pressures versus age are these dots. So if you strip away the lines and the equations that I wrote in, all you have are the data points, okay, that's what this one does, SBP versus age. That's that first plot. Notice that I then have, after the comma, I indicate whether the points should be connected. So connected is what C stands for, and what the symbol, the plotting symbol, would be. So the first graph is y hat versus age. The predicted values versus age. And I'm telling it to make the plotting symbol invisible, that's what the I means, and to connect the points with a straight line. That's a lowercase l. So what it did is it took the regression line, the one that's here, the darker line, and it basically plotted the points were invisible, And then it connected the points with a straight line. So that's that first line that you see is the least squares line that gets plotted with that value of 220 in it. I did the same thing where I stripped out the 220, and that gave me the bottom line. Okay? But the important point was that I told it to connect the points of the y-hats with a line and to make the symbols invisible. The second plot I'm doing is systolic blood pressure versus age. And they're not invisible. Those are little O's. That means used little dots. That's what it did there. And don't connect any lines. Don't connect any points. So when I give this command, I have two graphs in one. The first graph are the actual data points. The second graph is the straight line, which were invisible points, but you connected them with a straight line so that it looks like a straight line. Okay? And so that's how you would actually do this in Stata. Now, recall, so again, so once I looked at the computer output, but I know what the equation of the straight line was, and I already said that once you have that straight line, you could also plot it by hand. You don't have to rely on Stata to do that for you. Okay, so let's recall now that what we're going to call the error sums of squares is the sum of the square deviations of each observation, the true value of y, about the value of y that's predicted by the model. So you take that deviation, you square it, and you sum it up over all n observations in the data set, where the predicted value of y's are the beta naught plus beta 1 times x. But that's the regression equation. Now, if the error sums of squares was 0, how could that happen? How could the error sums of squares be 0? Well, the only way the error sum of squares can be 0 is if the observed value of y and the expected value of y are the same every single time. But as the fit gets worse, that is, as there becomes some deviation between the observed value of y and the predicted value of y, the error sums of squares grows larger and larger. So the bigger the error sums of squares, the worse the fit. Okay? If the error sum of squares is 0, you would have perfect fit. So again, these are the computer outputs that we've talked about. We've already gone through these ourselves together. Here you have the command for summary statistics, and here I've looked at the summary statistics in detail for age and blood pressure. Then here, again, I ran the regression model. The important thing to understand with Stata is that when you give a command like regress, the first listed variable is the dependent variable, and the next listed variable or variables are the independent variables. So the first listed one is always the dependent variable. And then the only thing that we really know how to look at in this output is here in the coefficient table, where we're being told that the intercept is 98.714 and the slope is 0.97087. Okay, so it's done all this work for me. I wanted you to see the formulas so you know what was going on, but then this is all extremely straightforward. It can be produced by any of the statistical packages that we talked about. Okay, now we're up to the assumptions necessary for linear regression, so we'll have another quick break.